Okay, hello everyone. It's great to see all y'all here. This is actually the first in-person conference talk that I've done. It's all been virtual or meetups before this. So it's great to see all of you in person. And I'm gonna be speaking on opt-in design, which I am dubbing a new era in web development, a new chapter. So to clarify what design means, first off, it's not a UI design talk, although graphic design is clearly my passion. It's also not a systems design talk. We're not doing UML diagrams. We're not doing whiteboarding, sadly. But it is an API design talk. So we're going to discuss what good defaults really mean, both in the tools you use and also the components and libraries that you author yourself in the open source community, and finding and building the best tools for the job, both in what you're building and also what you are shipping to other open source users. So to introduce myself a little bit, I already got a great intro there, but I'm a core maintainer over at Astro. You can find that framework, astro.build, and that's going to inform a lot of the examples that we talk about today. I call myself the Chief Whiteboard Officer, because CEO of Whiteboards, we have a CEO, I'm not a CEO. But I do make whiteboard tutorial content over on wtw.dev if you're ever interested. And I'm the champion of content. So if you're building content sites, you like Markdown, MDX, MarkDoc, love all those formats, and I maintain some of the integrations at Astro for those. So I'm going to start by walking through building an app from start to finish. And I'm going to start with a pretty uncontroversial example of how we built things, maybe like 2016 era with the Create React app. So when you're building your first application, you start with the hello world. You see something on the screen. And if you're reading the blog post of the time, you're probably reaching for a combination of React and React DOM, the new hotness, using maybe React Router in order to manage all of your SPA routes. And you're reaching for something like styled components so that you can have those scope styles co-located with your component and making them reactive to state variables. All the stuff that you probably need. And you can see right away, I have a little kilobyte counter in the corner. This is not the only metric to optimize for, but it can be something to keep in mind when you are shipping a lot of JavaScript stuff instead of doing that work on the server. And you can see, we walk up to more features we need to add to our application, maybe a sign-up form. And you want to start by, the old patterns, prevent the default behavior, manage it using React instead of using a server post request. So you're giving up some progressive enhancement there, but you're at least getting some interactivity. And maybe you're using Formic in order to validate that form and show error states. You see our ticker going up a little bit in the corner because we're shipping more to the client in order to make it feel dynamic. And then we go a little bit further. Now we have a full e-commerce experience maybe. We need to manage the client state in order to make sure it mirrors what's going on the server. The person is logged in, they have 2 items in their cart. That bubble better match whatever is being stored server side. So you might stick that in React context so everyone knows what's in the cart. You have a cart flyout that's unrelated, so the context needs to wrap around that. And you're adding some more client-side JavaScript to sort of replicate whatever the server has. And then you get to your performance audit. And it's fine. Everything is fine. But you might be surprised using these tools. You were kind of told this is how you build apps these days. Like, well, I didn't do any work on the server because I didn't really know how to do that with React, especially when it was hard to server render. And you are hurting that time to interactive because you need to load up a bundle up front before the user sees anything, including the hello world that we started with. So this takes us to some of the pains of this opt-out mindset that I'll kind of call it, and we'll break down the points later. But there are a few pains that you run into with those early libraries. Create React app, for example, the happy path, let them manage your whole Webpack config. No one likes touching Webpack, it's a scary thing. So we're going to use whatever Create React app gives us to build our app. And if we ever need to opt out of what they need, well, you need to eject and manage the whole thing yourself, which is a scary proposition. It's why people usually stick with that default and never opt out. The second pane is with styled components. The default is JS first, CSS as the output that gets rendered into your components. And slowly over time, new patterns emerge. There's a great blog post from Josh Komu about using CSS variables instead of the props object so that you can manage your state with pure CSS variables without having to ship big bundles for it. But again, that's an opt-out from some of styled components' early patterns, and you're looking at things in a new way. So you need to be smart about, understanding what the tool is doing and then figuring out when you need to switch from the doc's recommendation if you need to. The last one, the pane of React context. Of course, when you're hoisting state high up, it's very beneficial if it needs to be used everywhere. But if you're writing aggressively, you have a lot of re-renders. You need to performance monitor those. You need to know where that's happening. And it can be expensive, easy to overdo, of course, and you opt out with the use memo lever. That's going to cache all the results. And you need to be smart about use memo pretty much everywhere in the tree that relies on that context if you run into those issues. Again, performance auditing, but that's on you to figure out later on. The default is pretty much just good enough in order to re-render. So some ethos here, it assumes a goal in whatever tool that you're using, lower developer friction as much as possible, hide Webpack, hide the JavaScript to re-render styles, and just give you some hooks in order to do it. And you want to bundle all those tools up front. We use style components ahead of time, even when we weren't sure we needed it yet. And that'll hide complexity from you, but you might end up dealing with that complexity monster later if you run into problems and need to debug your tools to figure out what did it actually ship? I honestly don't know. So let's flip this to an opt-in mindset. I'm going to use Astro as the basis for my example, but using the PESPA frameworks that Kenzie Dodds mentioned. Remix is also an option for that. NextJS as well with server components. But when you start with the hello world in Astro, you'll notice your client.js kilobytes are still going to be 0. It's a server templating language. It gives you a basic pages router, but that's kind of it. The rest of it is something that you can bring to the party. So when we go to our sign-up form, for example, you can be as fancy as you want. In our example, maybe we just do a plain old post request on a form. We use Zod in order to validate those inputs client-side, so if you type a bad password or something, it doesn't have to do a round trip to the server to find out. But with that, you only need those 8 kilobytes for validation, but you don't really need anything else. You're not blocking the page in order to mount all of these crazy tools. You're just shipping in Zod when you need it. And then you get to the cart state that we talked about earlier. State management is its own can of worms, and you can also use session storage and server state. But if you wanted to use those client-side patterns, you might end up with a cart bubble. In Astro, you can opt in to using a client-side framework by just adding it from the CLI. Astro add React. You could add Vue, Preact, whatever you want. And you could maybe use nano stores in order to keep that state global and be able to use it in little islands of interactivity throughout your app. That's definitely an option. You can also just ship it to a server. The default in Astro is static builds. Static is always a great default, but you can opt into the complexity of managing a server by installing an adapter like Astro Add Node. That turns it into a node server now. And you could use session storage and middleware in order to keep track of how many items are in the cart. And then you could server render the whole thing, maybe not have React context in order to keep that up to date. Depends on how you want to do optimistic updates, etc. But all of the complexity is there for you to maintain if you want to. And when you get to the performance audit, well, we, obeyed the fact that HTML is a beautiful default that ships things like post requests in order to manage all of this. And we ended up with pretty fast time to interactive, option for server if we need it. And we understood the tools when we added them. We didn't read a blog post and start with the kitchen sink. We added things through a CLI that was easy for us to understand. So this takes me to some opt-in design principles that I think carry across frameworks. So the first, finding the lowest common denominator. The second, making complexity easy to add when intended by the developer. And the third is staying user first when you're designing these tools. Developer experience, of course, matters, but if it's not for the user's benefit, it might not be the best tool, especially if it is detrimental in some way. And we'll break down each of these. So the first around finding the lowest common denominator, you want to start with what the simplest use case for the tool will be. So the use case for the framework or the library that you're building. And for React, for example, the simplest use case is just rendering some text to the page, the hello world, the marketing splash page, whatever that is. So you want to make sure the default is optimized to make that experience really fast. Like just server render it, ship it to the user, and that's it. That would be the best default. And you don't want to do a car with opt-in wheels, of course. If your target audience is to build an application, you're assuming client-side state. Well, now something like NextJS, which ships a client-side router, that's actually a good default that you can build on top of. It really depends on what the target is going to be. I'm not going to, JavaScript shame anyone. The second one, you want to make complexity easy to add, but only when intended by the developer. So don't start with that kitchen sink and have them look up docs on if they need to remove it. And make them accessible, whatever you're trying to do. In Astro, we make the CLI as painless as possible. When you run Astro add React, it's going to set up your TS config, it's going to add React to your dependencies and ship it on the page for you when you use components. So that way, if you want to opt in, it's easy enough. You don't have to read docs to understand it, but you don't have to add it if you don't end up needing it. The last one, of course, stay user first in all of your tools. Lower the complexity baseline. It can often lead to better user experience. Complexity is in how complex the application is when it's shipped, not necessarily how complex your tools are. You only want to, ship the bundle that you yourself can understand and what the user needs to download. And I'm not just going to say time to interactive is what you need to optimize for. You might also care about re-render performance. You have a crazy interactive table with tan stack table, and you want to make sure it re-renders cells optimally. That's when you need to understand your tools and make sure maybe it's using another framework like Svelte or Solid in order to make that faster. Security is another metric to consider. All of these matter, but you need to frame it by what is going to be best for the consumer for this thing. And there's a whole world of examples. We've talked about Astro to start, but there are some others. Dino is an interesting one that Node 20 is also picking up. They bring opt-in to permissions. So instead of running a script in the raw and letting it do whatever it wants to your file system, you have flags that will opt in to allowing certain permissions. Like here, we're allowing access to our network to start a server, allowing file system access to read, and access to the environment to get our environment variables. Ideally, it wouldn't have to do this on its own. So that's when we get into our three principles here. How does it meet up? Well, the first one, the lowest common denominator is met. You might have a simple CLI tool that doesn't need any I/O. An example is like a text adventure game. Don't give it any permissions, it's just a text adventure. But if it needs to start a dev server, okay, now we're gonna give it access to serve things. And the additive complexity is there. We're using flags that are human readable, and they're granular enough that you can only opt in to the permissions that your app actually needs. And of course it's user first. We're caring about security vulnerabilities here. If I download a script off of NPM, I want to make sure when I run it that I'm giving it the permissions that it expects. I've seen this in mobile as well, like allow access to your contacts, your documents folder. It's kind of spreading across all of the software we use. And it's honestly overdue for the Node scripts that we run blindly. So it's good to see that. And the next one I'm going to talk about, server components, everyone's favorite buzzword. It spreads across both React server components and Astro in how we do server templating. And those bring opt-in to a few things. The first one being client-side JS. So here I have a very simple example. We have our server template rendered here, and we see some fun front matter tags at the top. This is going to be your server logic, so you can write any JavaScript you want to go fetch some information, maybe as a server endpoint or as a static build, and you have access to those variables inside of your template. Here I'm just using it to import a component, but you can do whatever you want. And when you render stuff inside that server template, it's server rendered. So you're not going to be shipping, a client hydrated component. You're just going to have, JSX templating that you enjoy, but rendering out server HTML at the end of the day. And then when you want to add in some interactivity, first you can Astro add React to opt into that library. And then you can opt into also shipping client.js with that. The default in Astro is to use components like React to server render, but you can add a decorator like client visible to say only load the client.js when it's visible on the page. So if it's an image carousel below the fold, for example, you might say only load that image carousel library when I scroll to it. So that way the initial page load doesn't even have to care about React. And you can, of course, make that flexible to any directive you want. It's similar to use client in the React server components implementation as well. So again, through our principles, the lowest denominator is static homepage, 0 JavaScript. That's going to be the baseline. Additive complexity, you can choose your framework and you can choose to hydrate it when you need to. You can server render, you can also opt out of server rendering if you want. It's just a switch. And then user first, we are thinking about maximizing those core web vitals. We want to make that time to interactive the best because Astro is focused on content sites. So it's really about getting that text, those images, whatever, to you as quickly as we can. And then we also have opt-in to streaming. This is a fun one that we're going to do a live demo of in a moment. But you can see here I have some server rendered code, very similar to Astro. We're just going to render that out. And then our albums might be a long fetch call to an external API. And we realized through user testing it made our page too slow to block on this. So we'll add suspense in order to show a spinner and stream in the information when it's available. And this, again, really approaching the similar things to Astro. Server render everything and avoid spinners if you can, because spinners have the consequence of layout shift, not the best default. Only have to care about skeletons and layout shift if it's actually something your app needs. So the default is going to be blocking, and then you can unblock with suspense. It's additive complexity because streaming is complicated. Make sure you only add suspense when you need it. And it's user first because of that layout shift I mentioned. So, okay, show of hands before the last example. Has this ever happened to you using React? Surprisingly, few hands. Usually everyone shoots up on a Zoom call, but okay. Yes, so this is the consequence of use effect. The default in React is, of course, re-render whenever a state variable changes. And if you don't realize the consequences of that, you could have it infinitely re-render, depending on how you hold it. So solid is a fun example here, bringing opt-in to reactivity, comparing the two. Here's a explainer on Solid if you haven't heard of it. Declarative JavaScript framework building fast UIs with max control over reactivity. It's from Fireship, the second best YouTuber on the platform, because I'm also on there. You know how it is. Hey, we gotta say it. So, like and subscribe. We have two examples here, and these are actually written with two different frameworks, though at first glance you can't really tell. So this is a product shopping cart, and we have some state that we want to maintain inside of this, and I have working demos of both of these buttons. So, I might be double miking. Let me stand awkwardly to the side. So, okay, so we have both the, it might actually work. So we have a few state variables at the top. We have our quantity, which is actually being tracked as state, and price, which is calculated based on that. And we want to make sure that one is going to react to a change in the other. So in React, when you declare variables and you have a state that changes, it's going to rerun the whole function top to bottom. So it will recalculate your price, but if you're not careful with either your use effects or caching in however you're doing those fetch calls, it could also like refetch your shipping text in that same component. So the default is to recalculate everything. And in Solid, it's actually much different. You'll notice it will update the quantity, but it won't even update the price by default, let alone images and shipping text. That's because in Solid, the function isn't where reactivity lives, it's actually the state variables. So you can treat this more as a constructor that runs the first time that component pops into the page. So if you wanted to make one variable react to another, you can add a little execution function in front of it. This is like computed in Vue, for example, where you can tell Solid to re-execute this, and smart enough to track the dependencies inside of this, no dependency array necessary, and it sees quantity, knows to recalculate price whenever that changes. So now we get the exact reactivity we want, and we opt in when we hit problems of things literally not running. It's a little more nuanced in React, because yes, the default is everything worked how I expected, But if you didn't have loading states, you might not have noticed that you're fetching your product images every time until you do a performance audit and notice it later. So it's kind of nice to have an opt-in that's flipped around. And to explain that, it's reacting to where the state is used in the JSX. It doesn't even matter how you've structured your functions in Solid. While React, the unit of reactivity, is going to be the component function itself, so you need to be more mindful about how you use it there and opt out with use memo. And that pattern has taken hold really in a lot of frameworks outside of React. Svelte and Vue have a similar model. Svelte, they're literally using a $ operator in order to re-render one variable based on another. If you've used Microsoft Excel, that's kind of the parallel where you can use a $ for formulas in a spreadsheet, $ to calculate price, kind of what's going on here. It's a clever idea. And of course, you can use computed in Vue to achieve the same effect, but that's pretty much it. So now let me jump into a little demo here. I've got 4 minutes. I'm going to be very creative with this. But you can follow along as well if you want to. This is on my GitHub, bholmesdev/simple_RSC. This is a base React Server Components implementation that doesn't use NextJS. It is a learning tool for you to understand how server components work. I encourage you to play around with it yourself. I documented the code base if you want to implement it, but of course don't use it for production. Kind of goes without saying. But I have that pulled up right here. I've called it Abramix. I built this with Dan Abramov. Had the privilege of doing that on stream. So the pun is like, it's an audio mixing site, Abramov, Abramix. I think it's funny. Hey, some people do. All right, I'll take it. So at the moment, we don't really have much going on in this server component. We just have the static H1 up here and a little bit of Tailwind to make it bold. And at the bottom, you see this dev panel that's included with simple RSC. And this is going to show you what the stream is that's coming down the wire to render what's on the page. In this example, we're just streaming down the H1, and we're not sending anything else necessarily. There is React DOM in order to update and do routing if we ever wanted to add routing, but that's it, nothing else. And if we wanted to modify this to send more information to the client, we could just start adding new things. So if I go in here and I add in, my list of albums, which I'm going to fetch from a server, thank you Copilot, but I forgot my async, so it got a little bit creative there. This is going to do a database request. I've added in a little bit of buffer, but it's just fetching some JSON. It'll be a slow load in order to grab a list of albums. And then I'm going to render them onto the page with this component here. And this uses a few things. First off, it has a search box with some client-side JavaScript. Notice I opt in to use that client.js to let you search for albums. And we also have our list of albums rendered out from that server result. So a little bit of client state, a little bit of server fetching, and we should see all of that appear on the page as soon as I actually pass this little albums component here. So as soon as we do that, it waits a heartbeat in order to render everything on the server, and then you see all of your albums as well as client imports stream into Vue. So it is going to be blocking. All of these came in one large request, but chunked out in a few ways just to make the network a little bit snappier. And we can see the H1 comes in, it discovers our client import, and then it streams in all the HTML to render those albums. And the beautiful thing about that is we didn't have to make a database request to get the song list that we have to throw away or get something else. Kind of the thing you used GraphQL to solve earlier, but now we use it just with JSX. So here I've done my server fetch and I've rendered exactly the HTML needed for the client. So what you're seeing here is exactly what is being sent. You don't have to wonder what that JSON hydration blob is. This is it. This is the amount of kilobytes. And we might decide, this experience is good, but through some user testing we found we want the skeleton and the layout to be there, but the album list can come a little bit later. It's coming from an external API that we can't optimize, so we're just going to put it behind a spinner. And that's where suspense comes in. So this is server-side suspense, actually, and this allows you to define your boundaries for using HTML streaming, or React streaming. It's kind of a proprietary thing. But it'll let you put in a loading state, italicized loading, that's fine. And it will show that loading state before all of this comes in. So I'll refresh this a couple times to show you what's going on. It passes in the heading, then it shows the loading state, and then it streams in the rest of the information later. And we can see that in the server stream down here. We're not shipping a client-side fetch that fetches back to the server and then sends more information to the client. There's not a ping pong back and forth with React Query. It's just one server that is streaming in the information as soon as it's available. And React is smart enough to wire that in and put it where all of those loading bubbles are. It's out of order streaming, which is a very interesting concept. But you can see that down here, this server stream and this client import as well aren't going to come in until everything is ready to render. So that's my demo of server components. Opt into streaming, opt into client-side JavaScript, opt into sending database information by encoding it straight in the markup that you're writing. So thank you. I appreciate y'all for your time. If you enjoyed this talk and you also want to try some of the opt-in frameworks like Astro, encourage you to go join the Astro Discord, astro.build/chat. We have lovely docs and a support squad over there that you can link up with. You can also find me at bholmesdev everywhere, TikTok, YouTube, Twitter, X, whatever it's called these days. I'm over there. And I also have this little archive website if you want to look at it. And on my GitHub, you can find all of these slides, because of course I used Markdown to write them. We're all programmers here. Okay, thank you all so much. Appreciate it.